Today's objective, we're going to find out how to more precisely and accurately find the area of an oblong object. Generally, in math, we use pretty regular and precise objects such as triangles, circles, and rectangles, to which we have formulas that we can apply very easily. But in real life, we don't find that so often. So if you take a look at this object here, there's no real definite shape it portrays. So there's no just formula we could just apply and find the area. So generally, if we looked at the graph, the grid that it's on, one square being 1 unit, no specific length to it, but just a unit, we could just count every box that the oblong shape touches. And if we did so, we could get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So about 58, 57, 59 boxes, and it's very tedious to have to count boxes like that, and it's not very accurate. One, because you can forget while you're counting, like I did, or also because it doesn't really, even though you count the box that it touches, it doesn't really encompass the entire box, because it's a curved shape. It doesn't have that perfect line like a unit would. So there are other ways we could try to find the area a little bit more precisely. One way that I'll show you today is by finding objects that we're comfortable with and finding those areas and applying them all together. So if we look at the object, we could find more obvious shapes within it that are easy for us first. So like maybe here in the middle, we could find this rectangle. And then here's kind of like more of a triangle. That. And here we could have this kind of semicircle here. And here we might say it's a semicircle, but we could also maybe just apply rectangles. Because it doesn't encompass every part of it and there's a little extra, we can kind of compensate. It's not completely accurate. To get really, really advanced, we could use calculus, but for the aspect of this lesson, we wouldn't have to get so advanced. We just want to get a little more than just having to do every single tile or unit. So in the middle, if we look at our formula sheet here, we see that the area of a rectangle is length times width. So for the rectangle in the middle here, it looks like we got a width of 3 times a length of 6. So that's going to give us 18. And then right here we have a width of 1 and a length of 6 as well. So that's going to be 6. This one's going to be 1 by 3. So that'll be 3. And then for our triangle here, if we look at our formulas, triangle's area is 1/2 times the base times the height. So if we look at the base, it looks like it's about 3 times the height, which looks about 4, and then 1/2 of that. So that's going to be 12, and half of 12 is going to be 6. So that's 6. And then our half circle here, we know that the area of a circle is going to be pi times the radius squared. So the radius is going to be 1, 2, 3, 4, 5, 6. 6 squared times pi. So that's 36 pi. And if you had a calculator with you, and I don't, you could find the estimated value of 36 times pi. Again, that's estimation though, and we're trying to be as exact as we can be. So 36 pi is an exact answer because pi is not rational. So a calculator giving you numbers would just be an estimated amount, close as you could. But if you leave it as pi, it's way more precise. So the circle in total would be 36 pi, but we only have half a circle. So we'd want to divide that by 2, which is the same as 36 over 2 times pi, which would be 16? 17? I don't have my calculator on me. Let's see. And you know, the point of math really is, again, not to be a calculator in your head. You want to apply mathematic theories that are accessible and workable. And for more simple arithmetic, it's always okay to double check your answers with a calculator. So 36 divided by 2, 18. So we were close in our heads, right? It's good to think about. So it'll be 18 pi. All right. So now we found simpler shapes within our oblong shape that are more precise. And now we just have to add them up. So it's going to be 18 plus 6 plus 6 plus 3 and plus 18 pi. So again, we can apply our calculator. So 18 plus 6 plus 6 plus 3. It's going to be 33 plus that 18 pi. And again, I would like to leave the 18 pi there again because that is exact. 18 times pi. Pi being a rational number, when you plug that in your calculator, it gives you a decimal number and a very ugly decimal number, and you always would have to take however many decimal places you want. But it's always an estimate. So if you leave it as pi, and it's being multiplied by itself by that 18 plus 33, that is the exact amount of area that we found within our oblong shape. And now we know the exact measurement. So if we were having to do a garden, or if we had to mulch this kind of place or fill up, you know, an area of this that is very applicable in everyday life, we've now found a better, more precise way of doing that, because we won't have to waste our product, we won't have to waste our money buying extra, you know, buying for each tile that it just touched. And so now we know how to do that.